Hello everyone, my name is Guo Teng and I come from Dalian University of Technology. The paper I'm presenting today is Student Behavior Pattern Mining and Analysis towards the Smart Campus. Okay, first is background. Smart campus is a central component of smart city. Understanding the student behavior patterns is fundamental for smart campus, as the student behavior is a reflection of learning status and campus life. Currently, smart behavior analysis is becoming increasingly popular, like the early warning system and the student status monitoring system. However, understand the student behavior is not easy. Compared with the data from another industrial, educational data has unique complexities, such as heterogeneity of academic data, multimodality of campus life data, imbalance of abnormal behavior data, and the incompleteness of important behavior data, and also individual difference, innate talents, acquired efforts lead to the diversity of student behavior. So understanding different behavior patterns are challenged by their task nature and the data features. Today, the data in education related field is explored, and the emergence of educational big data lays the foundations for the fine-grained profiling of student campus life, and also the advance in deep learning and representation learning enrich the technology for educational data mining. Both of these advances provide us opportunity for the field of student behavior mining and analysis. So in this presentation, I just introduced three of our research about student behavior mining and analysis. First is sleep pattern mining. Sleep matters a lot for health and well-being. Poor sleep habit can easily cause serious problems, especially for college students. So understanding its impact and detect students with poor sleep habit is one of the important tasks of education management. But currently in this field, the primary method of data collection are the self-report and the questionnaire. And both of these methods suffer from the small simple size, social bias, and time consuming. So in this case, how to detect student sleep habit from a data-driven perspective is still a challenge. In this case, we first design a Poisson mixture model to detect the student sleep pattern. First, and second, we profile student behavior from various aspects and explore the influence of sleep habit. And we conduct a comprehensive experiment on a large-scale education dataset. And the result demonstrate the effectiveness of our method. Okay, first, we have an assumption of this research. We assume a student surf internet before going to bed. In this case, we use the time of last network signal every day to quantify the time students go to bed. Okay, based on this assumption, we first define the aggregated sleep count, ASC. The ASC represents the total number of days a student go to sleep at a period of time. Let's take 0 a.m. as an example. Let's see the calendar. The student sleep at 0 a.m. on 4 days. So then the ASC at 0 a.m. is 4. Okay, based on the ASC, we can have the ASC vector. Right, is like this. The ASC vector represents the times of student fall asleep in each period of time. Actually, the ASC vector is a Poisson distribution. If one student is a Poisson distribution, in our dataset, we have 5,000 students. So it's a kind of a Poisson mixture model, right? In this paper, the parameter of the Poisson mixture model are estimated by the EM algorithm. Actually, is a it's a common parameter estimation method. So I won't go into detail here. Let's skip to the result. In this research, we divided the students into 3 subgroups: the freshmen, the sophomores, and the juniors. And we do the cluster experiment for each group individually. Let's take the freshmen as an example. We cluster the freshmen into 2 groups. The first and the second. The first group is the yellow person distribution, and the second is the blue person distribution. Obviously, the student compared with the yellow person distribution, student of blue distribution is more likely to stay up late, right? And based on this result, we also explore the impact of sleep pattern. And because of time, I won't go into detail here. If you are interested in this part, and you can find more information from our paper. Okay, next is friendship network mining. The friendship play an important role in everyone's life, whether in personal development or social well-being. Friendship matters a lot for everyone, especially for university students who are not physically and mentally mature. Taking class together is one of the main ways for students to build friendship. So in this case, class-level friendship network have attracted tremendous attention. But such an important data of student is invisible and difficult to collect it, which pose a challenge for education management. In this case, a significant topic of educational research is to discover the class-level friendship network based on a data-driven method. In this case, we first design a framework for students' class-level friendship network discover based on student information in the education management system. Second, we propose a deep adversarial optimization strategy for game-based model to solve the problem caused by the sparsity of adjacency metrics in the network discover experiment. And also we conduct comprehensive experiments on the real-world dataset, and the result demonstrate the effectiveness of our framework. Okay, this is the overview of our framework. And I only introduce the innovation. First is the academic performance representation. As I mentioned before, the heterogeneity of academic data is a big challenge for educational data process. Here, I just use an example to introduce what's the heterogeneity of academic data. Let's see, we have 2 students, Jack and John. If Jack takes 2 courses, computer theory and statistics, John takes 3 courses, computer theory, data structure, and matrix analysis. If we want to use the exam score to represent their academic performance, for Jack, we got a 2-dimension vector, but for John, we got a 3-dimension vector, right? As you can see, the content and the dimension are all different. So in this case, we first use a method is like a one-hot embedding, but the difference is when the student takes this course, we put the exam score here. If a student didn't take this course, we put a 0 here. So after this step, we have the 2 vector with the same dimension, but the 2 vectors are very sparsy. In this case, we use the autoencoder to obtain the low-dimensional dense representation. Okay, next is the ID photo. Actually, this is a kind of a common processing method. We use a autoencoder with a convolutional layer. Okay, I don't waste time here. Next is the behavior similarity. In this research, the behavior similarity is measured by their co-occurrence of canteen. Each co-occurrence is defined as two students generating records in the canteen with a short time interval set as 1 minute. Okay, this is the generation model. In our research, we use the GAN to generate the friendship network. Actually, the generate the adjacency matrix of a friendship network. But when we do the first experiment, the result is all zero matrix. The reason is the sparsity of a adjacency matrix of friendship network. So in this case, we have intuition. We want the model can learn from its own mistake. So in this case, we design the deep adversarial optimization strategy. The first is to train the model until convergence. The second is to choose an adversarial indicator to evaluate the generation result. If the condition meet, training over. If not meet, we put the generation result into training set as a negative case. Then we jump back to the step 1 to retrain the whole model. So in other words, the deep adversarial optimization strategy can make the model learn from its own mistake. For example, if in the first round of training, the result is all zero matrix, we put all zero matrix into the training set as a negative case. So in the next round of training, the model will realize the all zero matrix is incorrect and avoid make the same mistake. Okay, that's okay. This is a experiment result, and all the result just demonstrate the effectiveness of our models. So of course, if you are interested in the in this research, you can go to read the paper to get more information. Because of the time, so I only highlight some contribution, some innovation. Next is employment status mining and analysis. Help students find a job is a key task of a university, but not all students can find a job successfully. In addition to academic performance, the unconscious biases are a potential obstacle for the student who want to find a job. So it's necessary to understand the nature of such biases and predict the employment status of students in advance. So in this research, we first provide a comprehensive analysis on employment biases. And second, we design a bias-aware prediction framework to predict the student employment status in advance. And the second, we conduct a comprehensive experiments on a large-scale education dataset, and the result demonstrate the effectiveness of our prediction framework. The first is the result of bias analysis. In this part, we use the chi-square test to detect the bias from 3 perspectives, like the hometown and the ethnic groups and gender. The scatter plot represent the p-value of a chi-square test. Okay, next is the prediction framework. Our framework includes 4 parts: the academic performance representation, data augmentation, prediction model, and bias-based optimization. Okay, first is academic performance representation. This part I already introduced before, so let's skip this part. Okay, next is data augmentation. As we all know, the student who find a job successfully, the number of students who find a job successfully is more than the number of students who cannot find a job. So this data imbalance impact the training process a lot. The main idea here is that we use the GAN model to learn the distribution behind the data and then generate the new data samples to balance the dataset. Okay, the prediction model is the TCN model. This model is from another paper, and the information is here. The TCN is a neural network model for processing the time series data. Okay, the final part is the bias-based optimization. As we mentioned before, the employment bias varies by professions. Essentially, the bias represents the different importance of features for students in different professions. This could lead to the fluctuation in the model parameters during the training process, which could lead to the difficulty in convergence of the model. So to dynamically adjust the strength of regularization, we design a regularization factor, which can represent the severity of a bias. Okay, the last part is the prediction result. Okay, we will skip this part. Okay, this is the presentation today. I just give a briefly introduction of our research, but because of the time, so I have not presented too many details. So if you are interested in our research, maybe you can find you can read the paper to get more information. Okay, thanks.